guys, it's Ref from Into Gaming. Today's little video here is going to be covering the basics and intro overview on hit detection, aka registration, how it generally works, more specifically how it works with Unreal Engine and the character setup. So we're going to take a look at the character and its various components, its other classes that it works with and is bound to the actual character, and show you how the actual hitboxes are placed on the character class, on the actual mesh itself, and so forth. This was all spurred from multiple statements, threads, etc. in the PUBG Reddit, talking about this stuff, how like hitboxes aren't where they're supposed to be, etc., etc. So instead of going in some of these lengthy replies, because this stuff is complex, I just figured I'd do a quick video here. So anyway, jumping right into it, working with a basic character class. Its parent class is character. The character class was written by Epic Games, the actual developers of Unreal Engine. And what we have here is the components that I've inherited from that class. So we have the capsule component, we have an arrow component, the mesh, the skeletal mesh, and character movement. The capsule component is the actual base collision for movement. So when you're applying WASD, any kind of movement, jump, etc., you're actually moving this pill-shaped collision. And this pill-shaped collision is what interacts with the game world. You're not really moving the mesh, so to speak. The mesh is a child of the capsule component, so it's bound to that. So wherever the capsule component goes, the mesh will go. The mesh will have animations applied to it, so you actually feel like you're moving the actual mesh, and that is your character. The core of movement is through the character movement component. You can actually take this class, the C++ class, and extend it with additional movement, logic, and so forth. And most of this, the movement aspects of character movement are already networked, so the net code, so to speak, is already written into it. So when you extend off, you have to apply your own extra additional netcode stuff. So it's pretty straightforward stuff. But as far as the mesh, we're going to assign the mesh, and it's SK, prefixed SK, that's skeletal. So now we have a mesh in here, and with the mesh we are assigning an animation class. So the animation class is what actually applies the animation aspects to it. It uses animation sequences, montages, state machines, and loads of other logic to actually make the character animate. So with this character, let me go up here, let me compile that real quick, and we're going to just jump right to the actual character itself. The character itself is basically a static mesh that's movable, and it has a skeleton, and you can see the bones here that are shown here, and then a better view of the skeleton here. You can actually see all the bones that are applied in here. We have bones in the fingertips and everything, so we have all these different bones. The feet don't have little toe bones, but the hands have finger bones and so forth. So you get all the different little bones here. And beyond that, we have the physics asset. And the physics asset, let me actually go in here, character bones, selected only. Makes this a little bit easier to see. Let me drop this down a little speed. Now the physics asset here is basically all these little primitive objects are right around that are floating around the actual mesh of the body. These are small collisions, individual collisions. You have this one here. This is for the right hand. It controls all interaction, physics interaction, hits, and so forth to the hand. And you have one on the left hand, and then you have one. You have all these different little collisions. They're primitives. Actually, we can get down here and then the body setup, and we have primitives, and we get to capsules, and then we have the individuals. So that's basically when you're in a shooter, you're going to be actually hitting these collisions with your projectiles or your hit scan weapons. This is what you're going to be hitting. Now, with that, what we do, instead of, because we can report back a bone, let me actually jump to a projectile and run over projectiles real quick. This is a very basic projectile. You have a collision. That's what's going to interact in the game world. This is what's going to decide if it hits something. And then you have its movement. Just like you have character movement, you have projectile movement. This is the default built into Unreal Engine, written by Epic Games. Once again, it has a lot of different features. You can homing projectiles and so forth. You can do a lot of different things with it, bounces and so forth. But you're basically moving this collision component across the game world, and when it hits something, you see, scroll down here, I have on component a hit event. So when that collision hits something, we have outputs. It gives us outputs, and one of the big outputs is the hit structure. Hit structure lets it know if it's a blocking hit, what time, what distance from where it spawned, the location, the impact point, the normal, the impact normal, the physical material, hit actor, and so forth. So many different pieces of data that we use to determine what we hit and what next steps we're going to take based off of that. So for example here, I take the hit actor and I cast it to my demo character to see if I hit my demo character. If I hit my demo character, then the cast will be true, otherwise failed, and then I can go off, I can take the physical material, break that down into a simple string switch to tell me exactly where I hit, instead of versus, okay, what was the bone name? And if we look back at the actual skeleton, there's a whole lot of bones, and I don't want to run through that list of bones in a switch. That's a very long process. So to get past that, we define a physical material to the collisions. It's like simple physical material, like leg, arm. I think we have here is arm, and this will be arm, and then we get to this one, it'll be hand, and up here we'll have head, and we have chest. If I can just get in there, we have neck. We have, we simplified this whole structure so we have less code to deal with. So it's kind of universal. If you hit any of these two components here, you're going to do arm damage versus me looking at the bones. If I hit anything, any of the bones in the hand in that little collision, it's going to be a hand damage. And then I have foot damage, and then leg, leg, leg. So we're simplifying things, reducing that switch there. So you basically get into that. So this simplifies looking up bones, and then we can actually put all this in a function and pass this value, this physical material value, to a function to calculate damage, which does he have armor, does he have what kind of damage do you want to apply to it. So if he has a vest on and you hit him in the chest, then we're going to deduct X amount of damage. But if we want to, we can jump back and use the hit bone to apply some very specific little details. Like if it's hitting a leg, we can actually make you run slower. So we can set your maximum movement speed to X, Y, and Z for the various stances. So that's pretty much the basics of it. So when you're doing hits, when you're shooting at players, you're actually trying to hit some of these collisions. Jumping into the primitive aspect of these, the simplified collisions, we're using the simplified collisions because it's better on performance. I could technically come through here and let's click on the thigh and copy collision from a static mesh. So I could actually take the skeletal mesh, break it down into individual pieces, so I could have the thigh as its own little mesh, and the calf is its own mesh, and the foot is its own mesh, and then apply collisions to that, and then use that mesh to determine the collision. So we'll get more of a per poly kind of setup, but that's massive amounts of overhead and a performance hit. So yeah, I mean, that's basically it. Let me actually show you one more other thing. The other aspect of these actual collisions is they work with the physics of things. So when I go ragdoll, those collisions are what's interacting with the game world. Let me unsimulate. I'm giving you. Let's use an animation here. I'm gonna do walk. Do a walk animation, and I have this walking animation. And the physics aren't really doing anything in this, but watch when I hit because I have forward velocity applied in this. See how it just falls. And let's do a run. I hate how it actually, I do a run, and you can see how it's just going to interact with that, with the physics. Those collisions are what's actually handling the ragdoll effects. The other thing I just want to really quick get into, let me just do this real quick. Yeah, let me just browse to it. Let me open this up and show you what an animation is, so you get a better idea of what's going on with them. Alright, so animation is a bunch of still frames, and it's in a sequence. That's why it's called an animation sequence. A sequential loop of frames, and for running, this would be, you get roughly 17 frames to get the foot back to where it started. And what's going on with the animation is the engine is taking each frame of this animation. So from, let me just skip to the next one, to that frame, it's actually moving the bones, the skeleton, in the skeleton mesh to match that pose on a base frame rate. We can get into the play rate or rate scale, and we can increase the speed and decrease the speed and so forth. But that's in generally what's going on with the animation. We have a set animation set up here, and the engine is moving your skeletal mesh skeleton to mock that position. This is basically, an animation is basically a template for the movement system to animate your movement. But that's basically what I wanted to cover. Yeah, so if you have any more questions on this stuff, just let me know. I can definitely get into some serious detail with this. We can get into animation curves, montages, and all the kinematics, inverse kinematics, and control rig and stuff, and getting the mesh to do all kinds of crazy stuff and custom movement and so forth. So if you have any questions, just let me know.